Hi everyone, my name is Alyssa Hall and this is my presentation for my quantitative analysis midterm. So I used NFL Combine data to perform my analyses. So to begin, this is my t-test. My hypothesis was that there are no significant statistical differences between the 2014 and 2015 wide receivers in the 40-yard dash in the 2014 and 2015 NFL Combines. So my skewness and kurtosis, all of my data was normally distributed. And with my F statistics, according to the F stat, my value was 1.25 and it was less than the F critical value, so the data has equal variance. So I ran a t-test assuming equal variance. And according to the t-stat of 1.2, which was less than the t-critical value of 1.97, there is no statistical significance or difference between the wide receivers from 2014 and 2015 in the 40-yard dash. And my p-value was 0.3, which is greater than 0.05, so there was no significant difference between the wide receivers in 2014 and 2015 in the 40-yard dash. Therefore, my null hypothesis is supported. And then when it came to effect size, I calculated it, and the difference between these two groups yielded a Cohen's d value of 0.0465, which was less than 0.2, therefore it had no effect. So moving on to my correlation analysis, my hypothesis was that there is no statistically significant relationship between the height and weight in the 2013 to 2017 NFL Combine wide receivers. So I used several different years here. My skewness and kurtosis, the data is normally distributed. And with my correlation, there was a correlation between height and weight, and that R-squared value is 0.51. And then according to the significance table, this is a statistically significant value at the p equals 0.01 level. So I will be rejecting my null hypothesis. And then with my effect size, according to Cohen, this would be a large effect because the correlation is greater than 0.5. And here is my plot with the relationship between height and weight. And so as you can see, there is a correlation that as height increases, so does weight. So going on to my regression analysis, I hypothesized that the height, weight, vertical leap, and the broad jump can be used to predict the 40-yard dash time. So my skewness and kurtosis, all of my data was normally distributed, and so I performed an initial regression. And then I found that height is not a factor in the 40-yard dash time. Therefore, I went on to perform a second regression, and I found that weight, vertical leap, and broad jump can be used to predict the 40-yard dash times with a 29.7% accuracy. And so my hypothesis was supported with the exception of height. And here is my regression equation and my scatter plot that shows the relationship between actual and predicted 40-yard dash times. And so you can see the predicted value, the actual value, and then my R-squared value is where I found that percentage. Moving on to my ANOVA. My hypothesis is that there is no statistically significant difference between the vertical leap of wide receivers in 2014, 2015, 2016, and 2017 in the NFL Combines. So my skewness and kurtosis, my data was normally distributed, and then I went on to perform a one-way ANOVA. The results from the ANOVA suggest that there is no statistically significant difference between the groups. And I went on following my one-way ANOVA, and I performed a Bonferroni post hoc test where my new p-value was calculated to be 0.084, which when comparing 2017 to 2016 and then so on and so forth, the t-test that I ran showed no statistical significance for each comparison. So then I went on to compare effect size. There were several variations in effect size. I had 2007 to 2016 had a moderate effect size. 2017 to 2015 had a large effect size. 2017 to 2014 had a large effect size. 2016 to 2015 had a large effect size. 2016 to 2014, and then 2015 compared to 2014 both had small effect sizes. So moving on to my summary, for my t-test, the wide receivers in 2014 are just as fast as wide receivers in 2015. This could be because players overlap and stay in the league between years, and there's not a huge difference and not too many coming back in. Correlation, the taller you are, the more you weigh. Might seem like common sense, but we have the statistical significance to prove that with the correlation. Regression, weight, vertical jump, and broad jump do influence the 40-yard dash. So as your weight decreases and you lose fat, you can get faster, you can jump further, so on and so forth. And then with the ANOVA, there's no statistically significant differences. And even though that was the case, there were several moderate to large effect sizes. So this could be the large data set and the variance between years. So I am very appreciative for your time. I hope to hear really good feedback, and thank you for everything. Have a good time.